Imagine a world where every click, every stream, and every transaction happens seamlessly, no matter how many people are online at the same time. That is the power of scalable cloud architectures and APIs. These technologies work quietly behind the scenes, making sure that the apps and services we rely on are fast, efficient, and always available. As the digital world grows, scalability is no longer a luxury, it's a necessity. APIs, on the other hand, act as the lifeblood of modern systems, connecting applications and enabling real time data sharing. Without them, services like e commerce, streaming platforms, and even healthcare systems would struggle to meet user demands. We'll begin by looking at how scalable cloud architectures support resilience and performance. Next, we'll dive into the role of APIs in connecting systems and enabling innovation. Finally, I'll share real world examples to show how these technologies are making an impact today. Let's start by understanding the core of scalability and how distributed computing and containerization have revolutionized modern cloud systems. Distributed computing is a key feature of modern cloud systems. It involves spreading workloads across multiple servers to balance demand and avoid bottlenecks. This ensures that no single server is overwhelmed, which is critical for maintaining uptime and reliability. A great example is Netflix. It uses a global network of distributed servers to handle over 200 million users worldwide. This architecture allows Netflix to dynamically redistribute loads, ensuring smooth, uninterrupted streaming, even during peak times like new show releases. While on the other hand, containerization is another game changing technology in cloud architecture. Tools like Docker and Kubernetes allow applications to run in portable, lightweight containers that include everything needed: code, dependencies, and configurations. These containers make it easy to deploy applications consistently across different environments, reducing any sort of compatibility issues. Now that we have seen how scalable architectures drive resilience, let's explore how cloud elasticity optimizes resource allocation while cutting cost. Elasticity is nothing but the ability to dynamically allocate resources to meet changing demands. It ensures that businesses can scale up or down in real time depending on workload requirements. Think of it as a flexible backbone that adjusts to traffic surges and quiet periods without compromising on performance or wasting resources. Dynamic scaling allows cloud systems to adapt resource allocation in real time. It automatically increases capacity during high demand and reduces it during low activity. Consider a retail platform during a flash sale. Thousands of users might log in simultaneously, leading to a traffic surge. Dynamic scaling ensures that additional servers come online instantly to handle the load, providing a seamless shopping experience. Without this concept of dynamic scaling, businesses risk downtime, slower performance, or over provisioning, which can result in wasted resources and, of course, higher cost. Elasticity, while on the other hand, eliminates the need to over provision resources, where companies traditionally maintain extra capacity to handle peak loads. By automating scaling, organizations only pay for the resources they actually use, reducing infrastructure costs significantly, which is critical for any business. Let's say streaming platforms benefit from elasticity by scaling up resources during the evening when user activity peaks and scaling down during the early hours of the morning. Now that we have explored how elasticity optimizes resource allocation, let's turn our attention to the role of APIs in connecting systems and enabling seamless data communication. APIs enable systems to communicate and share data seamlessly, powering everything from social media integrations to enterprise softwares. And we can achieve this using new modern technologies like gRPC and GraphQL. So, what is gRPC? gRPC is nothing but a modern, high performance framework for API communication. It enables real time data transfer between systems while minimizing network latency. For example, gRPC is commonly used in microservices architectures to maintain smooth and quick communication between services. While on the other hand, GraphQL takes a different approach by allowing clients to request exactly the data they need, nothing more, nothing less. This reduces the amount of unnecessary data transfer, improving performance and efficiency. Imagine an e commerce app fetching specific product details for a customer without overloading the system with unrelated information. That's GraphQL in action. Together, these APIs provide more flexibility, faster responses, and reduce network overhead compared to traditional methods. So, we do have these new technologies, then why do REST still matters? Despite innovations, REST APIs remain the backbone of most integrations due to their simplicity and compatibility. In fact, over 80% of enterprise software systems still rely on REST for their integrations. Now that we have seen how APIs power connections and data sharing, let's explore how these technologies are transforming industries with some real world examples. E commerce platforms experience unpredictable traffic spikes, especially during major events like Black Friday sales or product launches. During a flash sale, thousands of users might log in simultaneously. Cloud technologies ensure the system can handle the demand, providing a seamless shopping experience with no downtime. These platforms also maintain 99.9% uptime during high traffic events, safeguarding critical revenue streams and enhancing customer trust. APIs enable features like personalized recommendations, real time inventory updates, and secure payment processing, improving customer satisfaction and loyalty. Streaming services like Netflix account for 60% of global internet traffic. Scalable cloud architectures ensures high quality, bandwidth efficient content delivery to millions of users simultaneously. And advanced APIs analyze viewer preferences to recommend content, creating a highly personalized and engaging user experience. Now let's look at how data-driven decision making powered by APIs is accelerating business execution and creating new opportunities. In today's fast-paced business environment, making informed decisions quickly is very critical. Data is the foundation of these decisions, and the ability to integrate, analyze, and act on data from multiple sources gives businesses a significant competitive edge. A unified data ecosystem is nothing but it brings together data from multiple sources into a single integrated platform. APIs play a key role in enabling this integration by ensuring seamless data flow between systems. Imagine a retail company integrating customer purchase histories, web analytics, and supply chain data. With a unified view, they can predict trends, manage inventory, and optimize marketing strategies more effectively. Uh, Faster analysis, faster decisions. Real time data sharing reduces analysis time, enabling businesses to respond 40% faster to market changes. Through real time data integrations, organizations can monitor performance, track KPIs, and make adjustments on the fly. This is particularly valuable in industries like finance, where timing is, of course, everything. Next, we'll explore how these scalable cloud technologies and APIs are shaping the future of industries, driving growth and fostering innovation. Cloud investments are projected to surpass $1 trillion by 2025, with 80% of workloads running on cloud platforms. The cloud is not just about storage or computing power anymore. It's a foundation of digital transformation, enabling businesses to modernize their operations, enhancing customer experiences, and staying competitive. Next, we'll discuss how these technologies can drive operational excellence by combining optimization, efficiency, resilience, and innovation. Optimization. Cloud technologies optimize resource usage by dynamically adjusting computational power to match the demand, maximizing resources during peak periods and minimizing costs during slow times. Optimization extends beyond cost savings. It ensures consistent, high quality performance across applications and services. Efficiency. APIs and cloud solutions automate repetitive tasks and streamline processes, saving time and reducing human error. Resilience. Scalable cloud architectures provide the resilience needed to handle disruptions, ensuring uninterrupted service even during unexpected demand surges or failures. Cloud systems simplify disaster recovery by enabling quick backups, failovers, and restoration process. Next, we'll take a closer look at specific case studies that illustrate how these principles have been successfully applied in real world scenarios. So let's consider the case where we had to manage peak traffic. So the challenges could be e-commerce platform receives massive traffic spikes during events like Black Friday, as we discussed previously. And the solution would be implementing the scalable architectures dynamically to handle surges, maintaining 99% or 99.9% uptime and faster loading times. For instance, consider Amazon, which ensures smooth user experience even with millions of simultaneous visitors. This also enables us to improve the performance. Faster loading times directly impact customer satisfaction and conversion rates. Studies show that a 1 second delay in page load time can reduce conversions by up to 7%. Next, let's explore another real world example, how APIs are streamlining operations and improving efficiency in healthcare. APIs enable seamless, secure access to patient records, improving care coordination. They automate repetitive tasks like scheduling, billing, freeing healthcare professionals to focus on the actual care. Next, we'll summarize the key takeaways and actionable insights from today's discussion. Scalable architectures ensure systems adapt to growth and demand surges, and APIs connect systems and enable efficient data sharing, powering seamless workflows and faster decision making across industries. Cloud elasticity minimizes waste and reduces cost by dynamically allocating resources to match workloads in real time. Finally, let's discuss actionable next steps about leveraging these technologies for any organization. So, we can start by analyzing the current systems, meaning like we need to start evaluating the current existing cloud infrastructure, identify any bottlenecks, inefficient and areas where an integration can add value. Transition to scalable cloud platforms to handle dynamic workloads, ensure high performance, and reduce cost. Consider platforms like AWS, Azure, or Google Cloud for reliable scalability. Use APIs to enable real time data sharing. We can focus on next generation APIs like GraphQL or gRPC to optimize performance and efficiency while maintaining network latency. Encourage teams to explore new ways to use cloud and API technologies, whether it's automating processes or launching innovative services. Ensure that your cloud and API implementations adhere to industry security standards and data privacy regulations. By taking these steps, any organization can unlock the full potential of scalable cloud architectures and APIs, driving efficiency, innovation, and growth. Remember, the goal is not to just adopt these technologies, but to align with them with your business objectives for maximum impact. Thanks for giving me this opportunity.